Rational Inequalities Part 1. Solve the rational inequality and graph the solution set on a real number line. Express the solution set in interval notation. Here we have a rational inequality because there's a variable within the denominator. In order to find the solution, we need to make sure that there's a single expression on the left side and a zero on the right side. And if we look at our problem, that is true, so we don't have to move anything. Next, we want to factor the numerator and denominator. Again, if we look at this inequality, the negative x plus 1 is already factored and the x minus 8 is already factored. So we don't have to do anything for that step. Now we're going to take the numerator and denominator and set them equal to 0 and solve for x. So I have negative x plus 1 equals 0 and x minus 8 equals 0. For the first one, I'll subtract 1 on both sides. I get negative x equals negative 1. Then I'll divide by negative 1. And I have x equals 1. Then I'll add 8 to both sides, and I get x equals 8. These are going to be my boundary points. We're going to take our boundary points x equals 1 and x equals 8 and plot them on the number line in order to get our intervals. Now before I write the intervals, I want to look at my original inequality. And here notice that I have an equal sign underneath my inequality sign. So that means that the boundary points are going to be included in my intervals. Now I also see that I have a rational expression. And I know that there's restrictions with rational expressions. So I'm going to take my denominator and set it equal to 0 and solve for x. This tells me that x cannot equal 8, because if it does, then my denominator will be 0 and my function becomes undefined. So when I do my intervals on my number line, I'm going to have a parenthesis by the 8, but a bracket by the 1. So 8 cannot be included, but the number 1 can be included. So we'll go ahead and write our intervals. My first interval is negative infinity to 1. My second interval is 1 to 8. And the 1's included, but the 8 is not. And then my third interval is 8 to positive infinity. Now we're going to take each of these intervals and select a test value to see if that interval is a part of our solution. So here I'm going to test x equals 0. When I do that, I get negative 0 plus 1 divided by 0 minus 8. This reduces to 1 over a negative 8, which is the same as negative 1/8. And negative 1/8 is not greater than or equal to 0. So I know that this interval is not a part of my solution. Next, we'll look at the interval 1 to 8. And I'm going to select x equals 2. When I simplify that, I get negative 2 plus 1 divided by 2 minus 8. When I do this calculation, I get negative 1 divided by negative 6. And a negative divided by a negative is a positive, so I have positive 1/6 is greater than or equal to 0. And this is a true statement, so I know that 1 to 8 is an interval that's a part of my solution. Lastly, I'm going to check the interval 8 to infinity, and I'll select x equals 10 as my test point. Now I have negative 10 plus 1 divided by 10 minus 8 is greater than or equal to 0. When I do this calculation, I get a negative 9 divided by 2. Negative 9 halves is not greater than or equal to 0. That means the only interval that works is the 1 to 8. So my final answer is 1 with a bracket by it and 8 with a parenthesis.